Some of the most useful things you can do in a garden look completely wrong the first time someone describes them to you. Burying cardboard, planting weeds on purpose, watering less to get more, leaving dead stems standing through winter. The instinct is to dismiss them because they contradict the tidy, controlled image of what productive gardening is supposed to look like. But the gardens that consistently produce the most food with the least management and the most resilient response to whatever the season throws at them rarely look like the ones on the covers of gardening magazines. They look like places where someone paid very close attention for a very long time and then had the confidence to act on what they observed rather than what they were told. These 50 ideas sit at the intersection of counterintuitive and genuinely effective. Some of them will save you money. Some will save you hours. Several will change something you've been doing the hard way for years without ever knowing there was another way. All of them are oddly, specifically practically useful in a way that broad gardening advice rarely manages to be. Painting the inside of a cold frame or greenhouse white dramatically improves the light quality available to plants growing inside it, and it costs nothing beyond a tin of white emulsion applied once to the walls and any solid internal surfaces. Light entering through glazing hits the back wall of a structure and is absorbed rather than reflected back toward the plants. A white interior bounces that light in every direction, increasing the total light available to plants growing against a back wall by up to 40% compared to an unpainted surface of timber or brick. The difference is most visible in winter and early spring when light levels are already low, and every percentage point of additional brightness translates into faster, stockier seedling growth. Apply it to the back wall, the side walls, and the base of any solid staging inside the structure, and you effectively extend the productive growing season at the low light end of the year without adding any supplementary lighting. Running a small electric fan in a greenhouse or propagation area for 2 to 3 hours each day produces stronger, stockier seedlings than any other single intervention available at the indoor growing stage at a running cost of pennies per day. Seedlings grown in still air develop weak stems because they never experience the mechanical stress that outdoor wind provides, which in natural conditions triggers the plant to thicken its cell walls and increase stem diameter as a structural response. This process, called thigmomorphogenesis, does not occur in still indoor air, which is why greenhouse-grown seedlings are frequently tall, thin, and prone to flopping at transplanting. A fan oscillating gently across the seedling trays for a few hours each day simulates that mechanical stimulus, producing plants with measurably thicker stems, larger root systems, and significantly better transplant survival rates compared to undisturbed controls. Position the fan so air movement is gentle across the foliage, not so strong that seedlings are bent flat, and run it during the daylight hours when growth is most active. Scratching the back of a seed packet with sandpaper before filing it away at the end of the season adds a reference mark that immediately tells you next spring whether that packet has been opened and used, and therefore likely has reduced viability, or is factory sealed and contains full-strength seed at full manufacturer-stated viability. Most gardeners keep seed collections in tins or drawers where opened and unopened packets sit together, and the frustration of sowing a full row from a packet that turns out to be half empty and past peak viability is a consistent source of early season gaps. A single scratch on the back of the packet after opening costs 2 seconds and creates a permanent distinction between new and used seed that works regardless of how many seasons pass between opening and the next time the packet is retrieved. Placing a strip of black plastic or black bin liner flat on the soil surface and leaving it in position for 3 to 4 weeks before sowing carrots, parsnips, or beets is one of the most reliable ways to dramatically improve germination rates in these notoriously slow and inconsistent crops. Your garden shouldn't feel like a second job, but for most people it does. You don't have weekends to spare. You don't want to spend a fortune on bagged soil and fancy tools. And honestly, you're tired of working harder every season for a smaller harvest. That's exactly why I put together The Simpler Garden, a complete 15-page playbook built for gardeners who want results, not rituals. Whether you're setting up your very first bed or rescuing a plot that's already run you ragged, this book tells you exactly what to put in place so the garden does the work, not you. It's available for a limited time only. Grab it now via the link in the description or by scanning the QR code on the screen. The black surface absorbs solar heat and drives soil temperature at the top 2 inches significantly higher than the surrounding unprotected ground, and warm soil germinates these crops measurably faster and more uniformly than cold soil does. The covered surface also retains moisture from any rainfall or previous watering, eliminating the drying out of the seed zone between watering that kills ungerminated seeds during the long wait for emergence. Remove the plastic the day before sowing, when the soil beneath it is warm and consistently moist, and sow into conditions that provide everything the slow germinating seed needs to emerge quickly and evenly. Keeping a dedicated pair of scissors hung inside the kitchen door specifically for harvesting, rather than relying on whatever tool is available in the shed when the mood to harvest strikes. Increases the frequency of harvesting significantly over the course of a full growing season, and harvest frequency is one of the primary drivers of total seasonal yield. The decision to walk across the garden, locate the right tool, and then harvest is replaced by a decision to grab the scissors that are already in hand and step outside. This sounds like a trivial observation, but the cumulative effect of harvesting twice as often is dramatic in crops like beans, lettuce, cucumbers, and herbs, where harvest frequency directly determines how much total food the plant produces before it terminates or bolts. A dedicated harvest tool at the point where the kitchen meets the garden removes the friction between noticing the garden needs harvesting and actually doing it. Soaking newly purchased bare root plants in a bucket of plain water for 12 to 24 hours before planting rehydrates root tissue that has dried out during transport and storage, producing an establishment rate measurably higher than planting directly from the package. Bare root plants, strawberry runners, asparagus crowns, fruit trees, roses, and hedging whips are harvested, sorted, and packaged at the nursery during autumn and winter dormancy, then stored and transported in conditions that allow some drying of the fine root hairs even in well-packaged stock. A single soaking session before planting restores turgor to root cells, activates the microbial coating on root surfaces that aids nutrient uptake, and allows the plant to begin its establishment from a position of full hydration rather than mild moisture stress. Plants soaked before planting consistently establish 2 to 3 weeks faster than unsoaked plants of equivalent size and quality from the same batch. A layer of used cooking oil poured into a shallow yellow bowl and left at the edge of any bed, experiencing aphid pressure, attracts and traps winged aphids more effectively than most dedicated sticky traps, at a cost of essentially nothing. Yellow is the color most attractive to flying aphids navigating by visual cues, and the oil surface prevents any insect that lands from escaping. Place the bowl at the level of the crop canopy rather than on the ground, change the oil every week as it fills with trapped insects, and position 1 bowl per 4 square meters of affected bed. The method works on winged adults, the mobile colonizers that found the bed and the ones looking to move to new plantings, rather than the settled wingless population already on the plants, making it a complement to direct control methods rather than a replacement. Its value is in intercepting the next wave of infestation before it lands and establishes. Mixing a small quantity of mycorrhizal inoculant powder into the planting hole of every transplant at the moment of planting, rather than sprinkling it on the soil surface where it degrades before reaching the roots, delivers the beneficial fungal spores directly to the root zone where they can establish their symbiotic relationship with the transplant immediately. Mycorrhizal fungi colonize root surfaces and extend the effective reach of the root system by up to 800%, improving access to water and phosphorus in the surrounding soil that the plant's own roots could never reach. The product must come into direct contact with roots to establish. Applied to the surface of a planted bed, it is degraded by UV light and soil disturbance before it reaches any root. A pinch of powder pressed into the base of the planting hole before the transplant's root ball is inserted establishes contact immediately and produces measurably faster establishment across the full range of transplanted vegetables, perennials, and shrubs. Cutting the top off a clear plastic bottle and burying it neck down in the soil beside a heat-loving plant like a pepper, aubergine, or melon creates a funnel that delivers water directly to the root zone at depth, regardless of how dry the soil surface becomes in high summer. Pour water into the buried bottle, and it descends gradually through the narrow neck into the soil at root level, bypassing the evaporation-prone top layer entirely. The delivery rate matches the absorption rate of most soil types, preventing the runoff and pooling that direct watering produces on dry, compacted summer soil. One buried bottle per plant, supplying a slow, deep drench every 2 days, maintains the root-level moisture these heat-loving crops need to keep setting fruit through the hottest weeks of the season, using significantly less water than any surface irrigation method and requiring no permanent infrastructure. Rolling seed directly from the packet along the crease of a folded piece of paper rather than pouring seeds into a hand and attempting to place them from a cupped palm provides precise control over where each seed lands and at what spacing, eliminating the overseeding and subsequent thinning that both waste seed and create root disturbance in the surviving plants. The paper acts as a simple seed dispenser. Hold it between finger and thumb over the drill, tilt slightly, and tap gently to deliver single seeds at controlled intervals. This technique works particularly well for small to medium seeds like carrots, beets, lettuce, onions, and herbs that are difficult to handle individually but too valuable to sow by broadcast. A piece of standard A4 paper folded once takes 2 seconds to prepare and produces more precise seed spacing than any purpose-sold seed dispenser at any price point. Hanging a single CD from a string beside each fruit-bearing bush or vine, rather than across the whole bed in a random scatter, creates a rotating, light-catching deterrent that is more effective at disturbing birds than static, shiny objects, because the rotation produces unpredictable light patterns that birds cannot habituate to in the way they do to motionless, reflective surfaces. Static bird scarers lose their effectiveness within a week to 10 days as local bird populations learn they pose no threat. A hanging CD that rotates in the lightest breeze produces a constantly changing reflection pattern that triggers the alarm response in birds each time because the visual signal never repeats in the same way twice. Use monofilament fishing line rather than string to allow maximum rotation and hang at the height of the fruit rather than above it, where the reflection falls directly at bird eye level rather than overhead. Watering the compost heap deeply before adding a new layer of brown material, dry cardboard, straw, or wood chip, prevents the new layer from drawing moisture from the composting material below it as it absorbs water from its surroundings. Dry carbon material added to an active compost heap acts as a moisture sink, pulling water from the decomposing layers beneath and creating a dry layer that aerobic bacteria cannot colonize efficiently. Pre-wetting each addition of dry material before layering it into the heap maintains consistent moisture through the entire pile, which keeps the decomposition process active at every level rather than concentrated only in the layers that retained adequate moisture. A well-moistened heap, damp throughout but not waterlogged, decomposes at twice the rate of a partially dry one and produces finished compost in roughly half the time. Threading old garden hose through the stakes or posts of a climbing structure and then securing it at intervals creates a durable, weather-resistant tie point that outlasts string, jute, or plastic ties and does not cut into plant stems the way wire-based ties do under the weight of a heavily fruiting vine. Old hose that has become brittle or developed cracks is unsuitable for water delivery but perfectly suited to this use. The rubber is flexible enough to accommodate stem growth, durable enough to last the full season outdoors, and wide enough to distribute load over a surface area that prevents the stem bruising and compression that narrow ties cause. Cut the hose into sections of 20 to 30 centimeters, loop it around the stem and the support, and secure the ends together with a zip tie or a piece of wire twisted tight. A single old hose provides enough material for an entire season of plant support across a full garden. Placing a flat stone or piece of slate on the soil surface directly above a dormant bulb planting marks the location of buried bulbs through summer when the foliage has died back, and nothing above ground indicates that anything is planted below. The single most common cause of accidental bulb destruction is driving a fork or trowel into a bed in late summer and emerging with a skewered tulip or garlic bulb that was completely invisible from above. A surface marker placed at planting time and left in position through the dormant period costs nothing, requires no labeling or written record, and prevents the loss of bulbs that may have taken a full season to develop to a harvestable size. Use any flat, distinctive stone that contrasts visually with the surrounding mulch, and remove it when the emerging foliage makes the planting location obvious again each spring. Cutting the base off a terracotta pot, and inverting it over a pepper, chili, or young tomato plant on cold nights creates a miniature heat trap that concentrates ground heat around the plant stem and protects it from brief temperature drops that would otherwise cause blossom drop, slowed growth, or, in severe cases, chilling injury to the leaves. Terracotta has significant thermal mass. It absorbs heat during the day and releases it slowly through the night, making an inverted pot more effective than a plastic cloche at maintaining a stable temperature through the critical overnight period when the most damaging temperature drops occur. The hole at the base of the inverted pot, now positioned at the top, provides ventilation that prevents the overheating that can occur under a sealed cloche during the day, making it a self-regulating structure that provides protection at night and does not require removal in the morning. Brewing a simple weed tea, submerging a cloth bag of freshly pulled weeds in a bucket of water for 48 hours, then removing the bag and pouring the liquid directly onto beds, delivers a small but genuine nutrient input from plant material that was extracted from your own soil in the first place, returning it in a form that is immediately accessible to roots rather than the weeks or months a decomposing weed requires. The nutrients in weed tissue, particularly nitrogen in young leafy weeds, transfer into the water as the tissue begins to break down over the steep period, producing a weak but genuine liquid fertilizer from material that would otherwise be composted with no intermediate benefit. Use weeds pulled before they have flowered or set seed, which ensures the bag contains no viable seed that might survive the steeping process and re-enter the garden in the liquid. Growing a single pot of lemon balm beside the entrance to a greenhouse or polytunnel and brushing against it deliberately each time you pass releases the plant's volatile oils into the air around the structure, which repels aphids and whitefly that navigate by scent toward host plants. The primary attractant for many flying pest insects is the volatile chemistry of their target crop, and a cloud of competing scent at the entry point to the structure disrupts the navigation signals they are following. A single large pot of lemon balm, refreshed by brushing each time you pass, provides continuous scent release without any preparation or application. The plant itself requires nothing beyond water, and a reasonably bright position grows vigorously enough to be brushed multiple times daily without showing damage, and produces harvestable leaves for tea and cooking throughout the season from the same plant, providing pest disruption. Storing seed packets in a sealed glass jar with a small silica gel packet inside, the type that comes in shoeboxes and vitamin bottles and is usually discarded immediately, dramatically extends the viable life of the seed beyond the manufacturer's stated date. Seed viability deteriorates primarily through moisture and temperature fluctuation during storage. A sealed glass jar with a desiccant maintains a consistently dry internal atmosphere that preserves the moisture content of seeds at the level most favorable for dormancy and long-term viability. Stored this way in a cool, dark location, many seeds remain viable for twice their stated shelf life. The silica gel packets can be dried and recharged indefinitely by placing them in an oven at low temperature for 30 minutes, making them a permanent and zero-cost component of a seed storage system that costs nothing beyond a glass jar already present in most households. Planting bulbs of any type in wire mesh baskets buried in the soil protects them completely from the vole, mole, and squirrel damage that renders bulb planting in many gardens an exercise in frustration. Voles eat tulip and crocus bulbs with systematic efficiency, following the scent of newly planted bulbs to each location within days of planting and consuming them entirely, leaving nothing but an empty hollow in the soil. Wire mesh baskets, constructed from galvanized hardware cloth cut and formed into a simple box shape. Surround the bulb completely, allow root and shoot growth through the mesh openings while preventing any rodent from reaching the bulb directly. Build the baskets from hardware cloth with a 1/2-inch mesh opening, fold the sides up, bend the edges over to close the top after placing bulbs inside, and plant the whole assembly at the correct depth. Reusable indefinitely, the baskets eliminate the primary cause of bulb planting failure in areas with active rodent pressure. Running your hands firmly along the stems of seedlings in a module tray, mimicking the mechanical friction of a light breeze, for 60 seconds each day produces the same stem-strengthening effect as a fan without any running cost or equipment. The friction stimulates the same cellular response to mechanical stress that wind provides in the field, triggering the plant to increase cell wall thickness and stem diameter in a structural preparation for outdoor conditions. Studies comparing hand-stroked seedlings with undisturbed controls found that the stroked plants had significantly thicker stems and shorter internodes, the length of stem between each set of leaves, both of which are indicators of structural strength and transplant durability. 60 seconds per tray, run along the top growth, with an open palm in both directions, costs nothing, and produces plants that survive their first week outdoors significantly better than those that were never physically stimulated before transplanting. A copper wire ring loosely coiled around the base of a pot acts as an effective slug barrier at a cost significantly lower than copper tape applied around the full rim, because the surface area of wire in contact with a slug attempting to cross is sufficient to produce the electrochemical deterrent effect even without complete surface coverage. Use bare copper wire of at least 1 millimeter diameter, coil it loosely enough that there are small gaps between the coils, and place it around the base of the pot rather than around the rim, where it sits on the ground and intercepts slugs before they reach the pot surface. The oxidized surface of weathered copper wire is more effective than bright new copper. The green patina that forms on exposed copper is itself mildly toxic to slugs and adds a chemical deterrent to the physical one. Collect copper wire from old electrical cable and strip the insulation for a free source of bare copper in any household with access to a basic toolkit. Sowing sweet peas in autumn rather than spring, and overwintering the seedlings in a cold frame produces plants by late spring that are twice the size and vigor of spring-sown equivalents, setting flowers 6 to 8 weeks earlier and continuing to flower through the warmest weeks of summer rather than exhausting themselves in early summer before the heat fully arrives. Autumn-sown sweet peas develop a deep, robust root system through winter in cold but not frozen conditions, which produces the stem length and flower count that marks the difference between a productive cutting plant and one that disappoints. Sow in deep cells or root trainers to accommodate the long taproot sweet peas develop even as seedlings. Place in a cold frame where they experience cold without freezing, water minimally through winter, and begin feeding with a balanced liquid fertilizer in early spring as growth resumes. The resulting plants at transplanting are significantly larger, better rooted, and structurally superior to anything that can be achieved from a spring sowing. Laying a piece of bubble wrap across a seed tray after sowing and watering before placing it in its germination position creates an insulating layer that maintains the heat and moisture conditions the seeds need for germination without requiring a heated propagator or a propagation mat. The air pockets in bubble wrap insulate both ways, retaining heat from the growing medium and preventing the cold air above from reaching the seed surface. It also retains moisture by slowing evaporation from the growing medium surface, reducing the frequency of watering needed during germination, and preventing the surface drying that kills germinating seeds at their most critical moment. Remove it as soon as the first seedlings emerge and replace with the next tray that needs germinating. A single sheet of bubble wrap from any packaging can serve as the germination cover for an entire season of seed starting, reused for each consecutive tray until it deteriorates. Mixing fine sand with small seeds before sowing distributes the seed more evenly along a drill than any other method when working without purpose-designed seed dispensers. Carrot, parsley, and lettuce seeds in particular are so small and light that they cluster together when poured directly from a packet, producing a dense concentration at each opening of the packet rather than a continuous even distribution. Mixing a tablespoon of fine dry sand with the seeds in the palm of a hand before sowing distributes the seeds evenly through the sand, which can then be poured in a thin stream from the palm along the drill. The sand is completely inert and has no effect on germination, but its bulk makes the process of distributing seed along a row significantly more controllable than working with the seed alone. Silver sand, used for horticultural purposes, is the cleanest option, but any dry fine sand that is free of salt works equally well. Filling the gap between a wooden raised bed frame and the permanent hard surface of a path with a strip of brushed-in sand rather than leaving a shadow gap of bare soil eliminates the primary colonization route for ground-level slugs entering the bed from below and from the path surface. Slugs crossing a band of dry sand encounter a desiccating surface that most species are strongly reluctant to cross, particularly during daytime when the sand surface temperature is highest. The sand also fills a gap that would otherwise accumulate moisture, dead plant material, and the dark, humid conditions that slugs actively seek as resting habitat between feeding sessions. Top up the sand strip after heavy rain, when it may have compacted or been displaced by water flow, and keep the adjacent path surface dry rather than allowing moisture to accumulate in the junction between bed and path. Placing an upturned pot filled with damp moss or straw on top of a garden cane inserted among brassicas provides a dedicated earwig shelter that concentrates the local earwig population in a single, easily monitored and removed location rather than distributing them across the entire crop. Earwigs are beneficial predators of aphids. They consume significant quantities of aphid eggs and crawlers, particularly at night when most gardeners are not in the garden, but they also damage soft leaf tissue in high populations. The shelter approach concentrates them where they can be assessed and managed if numbers become problematic, while allowing them to operate freely as predators across the surrounding bed at population densities that are beneficial rather than damaging. Check the shelter daily and remove earwigs only if plant damage is observed. In most gardens, the predatory benefit of a moderate earwig population significantly outweighs any leaf damage they cause. Steeping a handful of rhubarb leaves in a bucket of water for several days and straining the liquid before spraying it on affected plants produces an effective treatment for aphids and small caterpillars from material that is toxic to eat but safe to handle with gloves and harmless to the soil. Rhubarb leaves contain oxalic acid at concentrations that are genuinely harmful to soft-bodied insects when applied as a spray, without the residue concerns of synthetic insecticides and without the cost of commercial organic sprays. Use only the leaves. The stalks are edible and contain far lower concentrations, and collect them through the season from any rhubarb plant as the oldest, outermost leaves are removed during harvesting. Wear gloves during preparation and application. Spray directly onto aphid colonies and caterpillar feeding sites in the morning, and avoid spraying on windy days when drift onto flowering plants could affect beneficial insects visiting them. The spray degrades quickly in sunlight and leaves no persistent residue. Threading climbing nasturtiums up the outside of a bamboo wigwam rather than letting them sprawl across the ground beside it produces a compact, productive combination planting that maximizes vertical space, while the nasturtium's natural pest management benefits operate at the height of whatever crop the wigwam supports rather than at ground level, where they have less influence over the climbing pest pressure on tall plants. A nasturtium trained vertically also flowers more prolifically than one left to sprawl, because the upright position exposes more of the plant to direct sunlight throughout the day, and the flowers are easier to harvest for salads and cooking when they are distributed along a vertical structure at a comfortable reaching height rather than hidden under a ground-level mass of foliage. Start the training early, before the stems become too long to direct, and tie loosely at intervals of 20 centimeters up the cane structure. Planting a row of tall annual grasses, such as ornamental varieties grown from seed sown directly where they are to grow, along the northern or western edge of a salad bed, creates a temporary windbreak that simultaneously reduces moisture loss from exposed leaves on windy days and provides just enough shading in the afternoon to delay bolting in lettuce, arugula, and Asian greens through the hottest weeks of summer. The grasses established quickly from direct sowing, require no staking or management through the season, and reach an effective windbreak height of 60 to 90 centimeters within 6 weeks of germination. At the end of the season, they can be cut and added to the compost heap or left standing through winter as habitat material. The cost of a packet of annual grass seed provides enough material to create a windbreak for several bed lengths, and the shade and wind reduction they provide can extend the productive harvest window of cool season salad crops by 2 to 3 weeks beyond what the same crops produce in a fully exposed bed. Keeping a spray bottle of rubbing alcohol in the garden specifically for wiping cutting tools between plants, a single spray on the blade, and a wipe with a cloth before moving from one plant to the next prevents the mechanical transmission of bacterial and fungal diseases between plants that would otherwise be spread on the cutting surface. Every cut made through diseased tissue leaves a coating of pathogen on the blade that is then introduced to the vascular tissue of the next plant cut with the same tool. This is the primary route by which mosaic virus spreads through a bean planting, by which fire blight moves between fruit tree branches during pruning, and by which bacterial canker spreads between rose stems during deadheading. Sterilizing the blade between plants costs 3 seconds and eliminates this transmission route entirely. Rubbing alcohol at 70% concentration is more effective than bleach solutions, which corrode metal tool surfaces with repeated use and evaporates cleanly without leaving residue. Planting leeks into holes made with a dibber, watering in and not backfilling the hole, is the correct traditional method that most modern guides have stopped recommending, even though it produces straighter, longer white shanks than any other planting technique available. The dibber creates a hole roughly 15 centimeters deep. The bare root leek transplant is dropped in so that its roots sit at the base of the hole. Water is poured into the hole, which draws the roots gently downward and settles soil around the base of the transplant without actually filling the hole. The surrounding soil gradually falls in naturally over the following days and weeks as watering and rain disturb the hole edges, and the leek blanches as it grows upward through the slowly filling column of loose soil. The resulting white shank is longer, more tender, and better developed than anything produced by a transplant bedded conventionally into a shallow hole with soil mounded around it. Growing any variety of perennial kale, the woody, tree-forming types that reach 1 to 2 meters in height over several seasons, against a wall or fence as a permanent background, planting provides year-round harvesting from a plant that requires no replanting, minimal feeding, and almost no pest management beyond the first season of establishment. Perennial kale rarely seeds itself, and therefore does not require the intensive seedling management of annual brassicas, is significantly more resistant to cabbage white caterpillar damage than annual varieties because of tougher leaf structure, and produces harvestable leaves in every month of the year, including the depths of winter when most garden beds are empty. Your garden shouldn't feel like a second job, but for most people it does. You don't have weekends to spare. You don't want to spend a fortune on bagged soil and fancy tools. And honestly, you're tired of working harder every season for a smaller harvest. That's exactly why I put together The Simpler Garden, a complete 15-page playbook built for gardeners who want results, not rituals. Whether you're setting up your very first bed or rescuing a plot that's already run you ragged, this book tells you exactly what to put in place so the garden does the work, not you. It's available for a limited time only. Grab it now via the link in the description or by scanning the QR code on the screen. A single plant against a south-facing fence reaches full productive size within 2 seasons and provides a continuous supply of nutritious leaf from that position for 5 years or more before the stem becomes too woody and a new plant is propagated from a cutting to replace it. Covering the compost heap with a piece of old carpet rather than a purpose-made lid retains heat and moisture more effectively than most rigid covers, insulates the heap against temperature extremes that slow decomposition in cold weather, and provides a surface that earthworms beneath the carpet edge colonize rapidly. The weight of the carpet also compresses any new additions lightly, improving contact between materials and accelerating the breakdown of coarse items that benefit from compaction. Old domestic carpet from any renovation project covers a standard heap completely, costs nothing, and provides better insulation than a plastic sheet, which can overheat the heap in summer while offering minimal insulation in winter. Remove it briefly to add new material, replace it immediately, and leave it in position permanently through both active composting and the finishing period. A heap under old carpet consistently matures 2 to 3 weeks, faster than an equivalent uncovered heap under the same conditions. Siting a bird bath specifically within the vegetable garden rather than on an ornamental lawn area brings insectivorous birds into the growing space daily, where they feed on the pests that are actually damaging the crops rather than foraging at the margins of the productive area. Birds that visit a water source within a space become comfortable in that space and begin to feed across it opportunistically. Robins, sparrows, and tits are significant consumers of soil-dwelling larvae, aphids, caterpillars, and slugs, the primary pest groups in most kitchen gardens, and a garden where birds are comfortable and frequently present manages these pest groups at lower population levels than one from which birds are excluded or discouraged. A bird bath requires only regular water changes and occasional scrubbing to remain attractive and hygienic. Positioned at a height of 60 to 90 centimeters above ground level, it also provides the birds using it with the elevated view they need to feel safe enough to stay and feed. Using the long cardboard tubes from kitchen roll and paper towel rolls rather than short toilet paper rolls for deep-rooted crops like sweet peas, beans, and sweet corn produces a biodegradable pot deep enough to accommodate the taproot these species develop before transplanting without the root circling that occurs in pots that are too shallow. Sweet peas in particular develop a taproot within 10 days of germination that can exceed 15 centimeters in depth, and a standard toilet paper roll cell provides only 6 to 8 centimeters before the root must circle or compress at the base. The longer kitchen roll tube provides 12 to 15 centimeters of unobstructed depth, allowing the taproot to develop naturally through the entire indoor growing period. Fold the base closed, fill with seed starting mix, sow 1 seed per tube, stand the tubes upright in a tray, and plant the whole tube directly in the ground at transplanting time without disturbing the root system at all. Pouring a line of wood ash across the base of a slug-prone bed rather than around individual plants creates a broad deterrent barrier that covers the full width of the approach route rather than a narrow ring around each plant individually. Slugs crossing wood ash experience the same desiccating discomfort as they do crossing any dry, abrasive material, and wood ash absorbs moisture particularly efficiently from the slug's body surface. The barrier is effective only while dry. A single heavy rain event dissolves it entirely, and it must be reapplied. For this reason, it works best under the overhang of a polytunnel or cold frame edge, rather than in open ground conditions where it cannot be guaranteed to stay dry. In protected growing environments, a fresh line of wood ash applied weekly along the base of each wall or edge reduces slug pressure in the structure significantly without any chemical intervention and with complete safety to plants, soil microbes, and any other organisms present, marking the north, south, east, and west orientation of established plants when lifting and transplanting them, scratching a small mark on the north-facing bark of a fruit tree or bush, for example, and replanting them in the same orientation prevents the bark scorching and sun scald that can occur when a plant that has always had its north face shaded suddenly has that face exposed to direct afternoon sun after being moved and replanted in a different orientation. The bark on the north-facing side of an established plant is not adapted to direct sun exposure. Its cellular structure reflects the conditions it developed in rather than the conditions it suddenly encounters after replanting. Reinstating the same orientation after transplanting is a small detail that most transplanting guides omit, and that eliminates a genuine establishment stress for any woody plant moved at any size. Growing parsnips in large diameter pipe sections, drainage pipe of 15 to 20 centimeters internal diameter, cut to 60 centimeters in length, and filled with a mixture of sharp sand and compost, produces consistently straight, fork-free roots in any garden where the native soil contains stones, clay, or other structural features that cause conventional parsnips to split and twist around obstacles. The pipe provides an unobstructed, uniformly textured growing column that the root descends through without meeting any resistance, producing a root shape limited only by the plant's own genetics rather than the soil it encounters. Push the filled pipes into the ground to just below the rim, sow 2 seeds per pipe, and thin to 1 after germination, and harvest by lifting the pipe vertically at the end of the season. The growing medium falls away cleanly, exposing the complete root without any digging. Reuse the pipes indefinitely by emptying, cleaning, and refilling between seasons. Keeping a small notebook in a weatherproof plastic bag hung on a hook in the garden shed or on the greenhouse door, used specifically for recording the date, the exact problem seen, and the exact intervention applied each time something is treated in the garden, creates a pest and disease management diary that becomes increasingly useful with each entry. A spray applied on one date, with the result recorded 2 weeks later, tells you whether that intervention was effective under your specific conditions with your specific pest or pathogen. The same information repeated across 3 seasons tells you which interventions reliably work in your garden, and which ones are being applied optimistically rather than evidentially. Most gardeners repeat the same ineffective treatments year after year because the gap between application and visible result is long enough that memory cannot reliably connect them. A written record closes that loop and transforms reactive treatment into an informed, evidence-based system. Watering transplants immediately before lifting them from a tray or pot, not when they are in the ground, but while they are still in the container, ensures that the root ball is fully cohesive and retains its structure during the lifting and transplanting process rather than falling apart and leaving roots exposed. A dry root ball crumbles when the plant is removed from its cell, separating the root mass from the growing medium and exposing bare roots to air and desiccation during the transfer. A well-watered root ball holds its shape, lifts cleanly as a single unit, can be placed into the prepared hole without the roots having experienced any environmental stress, and begins drawing moisture from the surrounding soil immediately rather than after a recovery period. Water the tray deeply 30 to 60 minutes before transplanting, allowing the water to distribute evenly through the growing medium without pooling, and the structural integrity of every root ball in the tray is maintained through the entire transplanting session. Placing a ring of ground coffee around the base of young brassica transplants creates a multifunction planting amendment that simultaneously provides a mild nitrogen input, repels slugs and snails through both the abrasive texture and the caffeine content, and attracts earthworms that prefer the microbial environment the coffee grounds create as they break down. Research on caffeine as a molasticide found concentrations far below those in fresh coffee grounds were sufficient to produce avoidance behavior in slugs, suggesting that used grounds, which retain a meaningful caffeine residue even after brewing, provide a genuine deterrent rather than simply a physical texture barrier. Apply a ring of approximately 2 centimeters depth and 5 centimeters width around each transplant immediately after planting, refresh after heavy rain, and avoid applying in a thick layer that could crust and repel water from the root zone. The grounds break down into the soil within 2 to 3 weeks, releasing their nitrogen content at the same rate as any organic nitrogen amendment. Growing asparagus from 1-year-old crowns rather than 2-year-old ones, a counterintuitive recommendation that runs against the conventional wisdom of buying the largest available crowns for faster cropping, consistently produces more productive beds over the long term because younger crowns transplant with significantly less root disturbance and establish a deeper, more extensive root system in the first growing season than older crowns, which have developed a more complex root architecture that is more difficult to handle and transplant without damage. Trials comparing 1- and 2-year crown establishment found that after 3 full growing seasons, beds started from 1-year crowns produced equivalent or superior harvests to those started from 2-year crowns in the same soil, with the 1-year beds showing visibly stronger crown development at the base. The 1-year crowns are also consistently less expensive, making the faster is better argument for large crowns a commercial incentive for nurseries rather than an agronomic one for the gardener. Using the base of a discarded wooden pallet laid flat on a cleared garden area as an instant cold frame base for starting seeds in early spring encloses growing trays within the ventilated structure of the pallet, which raises them slightly above the cold ground surface, improves air circulation beneath the trays, and provides a rigid surface that keeps the trays level and secure without the risk of them being displaced by wind or disturbed by wildlife. Cover the pallet with a sheet of clear polycarbonate or a repurposed window frame, weight the edges securely, and the interior creates a microclimate several degrees warmer than the surrounding uncovered ground. The ventilation that the pallet's open structure provides beneath the trays prevents the moisture buildup that promotes damping off in the enclosed, humid atmosphere of conventional cold frames with solid bases. Pallets are available free in most commercial and light industrial areas and provide immediate utility as a growing infrastructure that requires no construction and no cost. Growing lemon verbena in a large container rather than in the open garden, then bringing it under cover before the first frost and allowing it to drop its leaves and rest in a cool, frost-free space through winter, produces a permanent plant that grows more vigorously and productively each season in the way that any established perennial does, rather than being lost to winter cold and replaced with a new plant each spring. Lemon verbena is technically a tender perennial that dies to the ground at temperatures below -2 degrees Celsius, which leads most gardeners in temperate climates to treat it as an annual. A plant overwintered in a pot in a frost-free garage or shed, even without any light through winter while leafless, breaks into growth the following spring with the energy of an established root system rather than a new seedling. By its 3rd season, the pot-grown plant produces more harvestable leaf from a single plant than 5 annual replacements combined, and the intensely lemony fragrance of established plant growth is noticeably stronger than that of a young seedling. Putting a date label on every container of homemade compost, leaf mold, and other slow-season amendments as they are filled rather than when they are used prevents the confusion of working through a stack of bags or bins of different ages and stages without any way of determining which is most mature. Finished compost applied to a bed is a fertility input. Unfinished compost applied to the same bed is a potential nitrogen thief and a source of plant pathogens that survive the incomplete decomposition process. A simple masking tape label on the outside of each bag or bin, marked with the month and year it was filled, allows you to work through your amendment stock in the correct order, oldest and most mature first, without pulling apart the entire storage area to assess which container contains what. Date every container at filling. It takes 5 seconds and eliminates all subsequent uncertainty about what is in each container and whether it is ready to use. Harvesting seeds from the very first and most vigorous flower of a biennial crop, the plants that bolt earliest and most strongly in the second year, selects over multiple generations for progressively earlier maturation and stronger flowering, which is the opposite of what most gardeners want from food crops, but exactly what is needed when developing a reliable seed-saving line from a specific variety. The exception to this deliberate selection for late bolting is when the goal is to build a productive seed crop from a variety that bolts reliably at the same time each year without variation, which is useful for crops grown specifically for their seed, coriander, fennel, and dill, where consistent seed production timing is more valuable than delayed bolting in the leaf stage. Knowing which selection pressure to apply when saving seed from different crops, selecting for delayed bolting in leafy crops, selecting for reliable timing in seed crops, produces a seed collection that serves your specific garden purposes rather than drifting in a random direction determined by whichever plants happen to set seed first. A length of flexible garden hose with small holes drilled along its length at 20 centimeter intervals, connected at one end to a water source and capped at the other, makes a functional drip irrigation line for curved or irregularly shaped beds that commercially available soaker hose cannot negotiate without kinking. Standard soaker hose is effective in straight or gently curving runs, but kinks sharply around tight corners, reducing flow to the section beyond the kink to almost nothing. A homemade drip line from flexible hose navigates any bed geometry, including complete circles, figure 8 shapes, and the irregular curves of naturalistic planting schemes, because the hose material is designed for flexibility, and the hole drilling pattern can be adjusted to deliver more water at one end of the line and less at another by varying the hole diameter or spacing along the length. A drill, a hose of any length, and a cap for the outlet end are the only materials required for a customized irrigation solution that cannot be bought off the shelf. The thread running through all 50 of these ideas is the same thread that runs through every genuinely useful piece of gardening knowledge. It was discovered by someone paying close attention to something that everyone else had either ignored or accepted without question. The folded paper seed dispenser exists because someone noticed that seeds poured from a packet clumped. The inverted pot cloche exists because someone noticed that terracotta retained heat after dark. The autumn sweet pea sowing exists because someone noticed that spring-sown plants never had the root depth of plants that had been in the ground all winter. None of these observations required specialist knowledge or expensive equipment. They required noticing and then doing something about what was noticed. The most useful garden knowledge you will ever develop will come from exactly the same place. These 50 ideas give you a head start on that process. The next 50 will come from your own ground, your own observations, and the particular conditions of the garden you tend every season. If this gave you something genuinely new to try in your garden, subscribe to Ageless Acres so you never miss what we discover next. And if you want to go deeper with us, exclusive guides, early access, and a community of gardeners who think just like you, join the Ageless Acres membership community, where we share the details, the failures, and everything in between. And for the books and research behind everything we cover, visit our book library. The link is in the description or right on the channel page.